Hi, everyone. Welcome to the Achieving Database Freedom with Amazon Aurora webinar. My name is Chuck Edwards, and I'm with Amazon Web Services. I'm the Global Partner Lead for Amazon Aurora and RDS, and I'd like to thank you for joining today to learn more about database freedom in Amazon Aurora. The relational database world has been an unpleasant place for most customers. These customers have had to deal with old guard database providers that are expensive, proprietary, have high lock-in, and impose punitive licensing terms. Commercial databases are significantly more expensive than open source platforms for even the most basic installations. Add in optional extras such as security and high availability, and the licensing costs escalate dramatically. In addition, each commercial database comes with an annual maintenance expense. Proprietary features included in commercial engines make it challenging to migrate and lead to vendor lock-in. At AWS, we offer a range of flexible solutions to help, including equivalent open source technologies and migration tooling to automate conversions. Traditional database contracts often force customers to license their database capacity for peak usage, which doesn't account for the dynamic on-demand nature of cloud workloads. If your database spend doesn't decrease when you have fewer users, it's time to consider AWS pay-as-you-go pricing. So while surprises can be fun, not so much with software licensing. Some databases let you unintentionally use unlicensed features, only to audit and charge you penalties later. At AWS, all our pricing is clearly documented, and you can't be charged for something you didn't sign up for. Because of the hostile practices of these old guard database vendors, we've seen many customers trying to move as fast as they can to open source databases like MySQL, Postgres, and MariaDB. However, getting the same performance on open source databases as you get on commercial grade databases is difficult. This growing customer feedback trend is why we built Amazon Aurora, which delivers the performance of commercial grade databases with the pricing, freedom, and flexibility of open source databases. Amazon Aurora is a MySQL and Postgres compatible relational database built for the cloud that combines the performance and availability of high-end commercial databases with the simplicity and cost effectiveness of open source. Amazon Aurora features a distributed, fault-tolerant, self-healing storage system that auto-scales up to 64 terabytes per database instance. Aurora also delivers high performance and availability with up to 15 low latency read replicas, point-in-time recovery, continuous backup to Amazon S3, and replication across 3 availability zones. Amazon Aurora provides 5x the throughput of standard MySQL and 3x the throughput of standard Postgres, running on the same hardware. This performance is on par with commercial databases at 1/10 the cost. You can easily scale your database deployment up and down from smaller to larger instance types as your needs change. To scale read capacity and performance, you can add up to 15 low latency read replicas across 3 availability zones. Amazon Aurora automatically grows storage as needed up to 64 terabytes per database instance. Amazon Aurora provides multiple levels of security for your database. These include network isolation using Amazon VPC, encryption at rest using keys you create and control through AWS Key Management Service, and encryption of data in transit using SSL. On an encrypted Amazon Aurora instance, data in the underlying storage is encrypted, as are the automated backups, snapshots, and replicas in the same cluster. The Amazon Aurora database engine is fully compatible with existing MySQL and Postgres open source databases and adds compatibility for new releases regularly. This means you can easily migrate MySQL or Postgres databases to Aurora using standard MySQL or Postgres import-export tools or snapshots. It also means the code, applications, drivers, and tools you already use with your existing databases can be used with Aurora with little or no change. Amazon Aurora is fully managed by Amazon Relational Database Service. You no longer need to worry about database management tasks such as hardware provisioning, software patching, setup, configuration, or backups. Aurora automatically and continuously monitors and backs up your database to Amazon S3, enabling granular point-in-time recovery. You can monitor database performance using Amazon CloudWatch, Enhanced Monitoring, or Performance Insights, an easy-to-use tool that helps you quickly detect performance problems. Finally, MySQL and Postgres compatibility make Amazon Aurora a compelling target for database migrations to the cloud. If you're migrating from MySQL or Postgres, see our migration documentation for a list of tools and options. To migrate from commercial database engines, you can use the AWS Database Migration Service for a secure migration with minimal downtime. So what are some common Aurora use cases? Migrations from commercial engines is one of the most common. Customers want to eliminate expensive database licenses, and with the enhancements the Aurora platform provides, we match and exceed the performance of many commercial engines. Migration from complex, highly available environments of MySQL or Postgres is another. With our operational automation and scaling capabilities, Aurora is an excellent choice for those who want to focus on the application and data and not worry about their database. And high throughput and large databases shine on Aurora with up to 64 terabytes of storage and 15 low latency read replicas. Thousands of companies have eliminated the exorbitant cost of commercial licenses by moving to modern cloud platforms on AWS with the help of the Database Freedom Program. AWS makes it easy to drop your old guard commercial databases, embrace the power of the cloud, and modernize your databases and applications. Using open source systems brings agility, flexibility, and significant cost reductions when compared to old world commercial systems. With AWS, you take advantage of a scalable, reliable, and secure global computing infrastructure. This virtual backbone of the multi-billion-dollar online business on Amazon.com has been honed for over a decade. Your database or data warehouse can scale based on demand. Backed by Amazon's massive infrastructure, you have access to compute and storage resources when you need them. AWS cuts your database costs with the pay-as-you-go pricing model, allowing you the freedom to pay for only the capacity you really need. Amazon Aurora offers an enterprise-class database at 1/10 the cost of commercial databases. Database migrations are an opportunity to modernize your databases and applications, ensuring that they're optimized and able to take advantage of the modern scalable database infrastructure available on AWS. Through Database Freedom, we offer technical guidance and on-site workshops through our team of migration specialists and database engineers, as well as our vetted APN partners who will engage with your organization to execute your enterprise cloud migration initiatives. Database Freedom support is available for migrations off of commercial databases to open source databases such as Amazon Aurora. To help offset the cost of a migration, AWS has an array of funding options available to credit AWS usage, support a proof of concept, and help reduce the cost of using an experienced APN partner. Funding will be tailored to meet your goals and can include credits for migrated data workloads and associated application servers. Contact your account team to find out more. Thousands of customers across every industry vertical have eliminated the exorbitant costs of commercial database licenses by moving to modern cloud-native platforms on AWS. One example is Verizon, who in 2018 announced they're migrating over 1,000 business-critical applications and database backend systems to AWS, including the migration of production databases to Amazon Aurora. Through working with these thousands of customers on their path away from commercial databases, we've consistently found that using our skilled APN partners can help accelerate the journey. Database Freedom partners have deep expertise in a variety of legacy database technologies, offer best practices for migration planning, migration tooling, including AWS Database Migration Service, and can guide customers through sticky business obstacles such as commercial database licensing. Many of these APN partners have been migrating customer databases between engines for years, even decades, and now they can help you take advantage of Amazon Aurora. And now I'd like to introduce you to one of our Database Freedom partners to talk more about Database Freedom and how they can help you get started with Amazon Aurora.
Thanks, Chuck. Hi, everyone. This is Raj Seku. I'm a refactoring lead at Clckwrk, and today we are going to talk about migration of Oracle to Amazon Web Services using with Clckwrk. At Clckwrk, we've been migrating Oracle systems from on-premise data centers to AWS for a number of years now. Our first Oracle ERP system went live in AWS in 2013, and since then, we've seen the appetite for moving from Oracle to AWS grow by leaps and bounds. This increased enthusiasm of customers towards migrating to AWS is resulting from a high number of innovative database-related services that AWS has been releasing in a very consistent and fast-paced manner. In the early days, we could move most customers' Oracle systems to EC2 architectures and use our management tools and services to look after the migrated systems. Then as the AWS platform matured and with the introduction of the RDS Oracle for databases, customers could rely more on AWS services and remove some or almost all of their management burdens of running the systems. We've seen the interest towards RDS, or the relational database service, has increased enormously after the introduction of the Aurora platform. Amazon Aurora platform provides a far superior and optimal performance in several key areas such as index reads or full table scans, which are considered the traditional Achilles heels on relational databases. Amazon Aurora can be faster up to 5 times when compared with a standard database due to its superior underlying storage mechanism. Alongside this is the trend for moving of proprietary systems like Oracle to open source alternatives. This has been evident given the compatible feature list of open source databases such as MySQL or Postgres is either equal or superior to proprietary database systems such as Oracle or Microsoft SQL Server. This, along with the availability of Aurora for MySQL and Postgres, has skewed the decision-making process towards a non-Oracle platform. A couple of years ago, we'd have this conversation with customers. There would be some interest, but relatively very low commitment. We could see that this was on the technology roadmap for enterprises, but would never make it into their budgeted projects. In the last 18 to 24 months, we have seen this conversation mature with customers first running pilot projects or proof of concept activities, and now running full-scale Oracle to open source migration programs. The market has matured, and we at Clckwrk have responded by creating our refactoring practice so that customers can move from plans and designs to the reality and benefits of replacing Oracle with open source alternative. Our approach fits hand in hand with the AWS DB Freedom initiative. We assess the customer workloads and grade their suitability for moving to open source systems. We then advise on which workloads are candidates for moving off Oracle, and we prioritize the workloads where the benefits are the greatest for the lowest given effort and cost. AWS Database Freedom also provides enormous flexibility in terms of certain aspects of application data, such as streaming time series or streaming stock codes that can be stored in a format that is scalable, unlike in traditional relational databases. This is often the case for in-house developed application and data stores where the application logic is in the control of customers, and the use of proprietary relational database features such as Oracle or Microsoft SQL Server specific features results in subpar performance. When these coincide with a workload using significant infrastructure to run an Oracle database, then we see that as an ideal refactoring candidate to move to open source systems. Why do customers migrate to Amazon Aurora? Amazon Aurora comes with it a very superior virtualized storage that provides up to 5 times faster disk I/O performance. Almost all of database performance relies on the speed of the disk I/O. Aurora will eliminate some or all of Oracle maintenance cost. The database administrator doesn't have to monitor the database throughout the day or be on call. Aurora removes the customer from having to spend their time and energy on compliance issues related to Oracle licenses or have to be part of a very time and energy consuming audit. And also the features in Postgres and MySQL, which are both the open source databases, are released more frequently than in a proprietary closed box database such as Oracle or Microsoft SQL Server. Here we have a case study. We have changed the customer's name on their request. This auto body, a collision shop with a few branches of their own in the central Massachusetts area. They have an estimates application that provides estimates to insurance companies and customers when an automobile comes into an accident. They had an Oracle database. They needed services of a network engineer, a dedicated Oracle DBA to manage their IT operations. They contacted Clckwrk for a solution, and we came up with a solution that is well-performant, auto-scalable, self-managing, and completely did away with the cost of maintaining, monitoring, and administering their systems. We used AWS Aurora along with the native services provided by Amazon, such as SCT, Schema Conversion Tool, DMS, Data Migration Service, all while the core business experienced 0-minute downtime. We helped and worked with the customers to migrate their application connection driver pool to the AWS Aurora instance in a seamless manner. The customer completely did away with the payroll cost for both the network and the Oracle database administration services. And we introduced the customers to the new and compatible Postgres related SQL features that enable them to continue with their application development stack. We also provided a cutting-edge state-of-art notification system using the serverless Amazon Lambda service, where a Python-based program would provide email and text notification to customers as their car or repair order moved from one state to another state, which usually is called the state transition in the automotive business. What are the challenges of migrating from an on-prem proprietary database to an AWS-based RDS or an EC2 database? The challenges are primarily the lack of knowledge where the Clckwrk comes in, and our approach to the refactoring work is to use the tools provided by AWS as much as possible. We use the SCT and DMS from AWS to help with the initial conversion of database schemas and migration of data. Depending upon the database schema's complexity, we would be converting anywhere between 50 to 80% of their business logic automatically using AWS provided tools. For some databases, it might be even higher if the stored programs have been completely written in ANSI SQL. AWS is doing a very good job of improving their SCT and DMS services in terms of adding more and more features to enable automatic conversion or migration from proprietary databases to open source systems. Um, and this would, I think, continue in future as AWS has a very dedicated development model to enable their customers from migrating from on-prem databases to the AWS platform. We are quick to remind that it doesn't mean that there would be 100% conversion of the on-prem database to the AWS platform. This is where our specialist refactoring team steps in. With their experience of converting databases, they can look at the reporting on non-converting objects from SCT and map these to the commonly used solutions for each type of problem. I'd give an example which is very familiar to many of the engineers or people who are familiar with database programs or applications. Often sorting of data in a database is a very high cost operation, and in Oracle, engineers would definitely use a manual sort area policy. In Oracle, it's called work area policy. In Postgres, it's called work mem. And we have experience in such nuances and dealing with those. We bring expertise to these cases because we've seen the same conversion problems before, and the same solutions can often be applied. Because coding techniques are often similar across systems and industries, the solution that has been used before can be used again. The conversion will be coded manually, but this is a very quick process because our teams know what code to target, what changes need to be made, and we have an exhaustive library that can do the remaining 10 to 30% of the conversion work that cannot be accomplished by the AWS SCT. Here is a deep dive into one use case that I'd like to share with you. You can see here the differences. The Oracle method of calling the next value in a sequence is different from that of Postgres. Postgres has more than one way of using the inbuilt character function to determine the substring of a text. And Oracle uses connect by prior to build a tree or relational tree or a management org structure, as we call it, using connect by prior. However, in Postgres, we would have to use a recursive CTE or a common table expression. The last portion of this solution, migration solution, is often the most complex, but it's not always hard because we have a very strong background in coding store programs on Oracle, SQL Server, MySQL, and PostgreSQL. We understand the subtle differences in implementation of the same features across different relational database flavors. To give you another example, a database link in Oracle is called an extension in PostgreSQL, or in other words, a database link in PostgreSQL has to be enabled as an extension. This is called as a linked server in Microsoft SQL Server. Unfortunately, in MySQL, there is no such concept as a database link at all. And we all use agile methodology. This is a sample project plan. We get in touch with the customers, we review and discover their business cases. Once the customer's funding is established, we create a team. We then go ahead and create the AWS infrastructure. We need to create the landing zones where the customer data can initially be staged prior to putting into an target EC2 or an RDS instance. We use AWS provided schema conversion tools and data migration service to establish a burn down for the conversion. And we use Kanban charts, and we use 1 week sprints, and then we sign off the project with the customer. All our projects, as have said, we use agile methodology. We have 1 week sprints to ensure that the drops in the customer bucket for user acceptance testing are very consistent and are available at the end of the day every week Friday. We have daily scrum meetings, we have a certified scrum master, and we have a thorough continuous improvement and learning methodology, not just for our build but also our deployment processes. And an important pillar of agile methodology is all team members need to have cross-functional and technical skills so that there is no single point of failure in the project, and all our team members can seamlessly complement and assist each others in terms of accomplishing our weekly sprint goals. We have a very thorough test and validation portfolio. We create an array of test cases to ensure there is zero tolerance in variation to the SOW and the specs that we have agreed upon with our customers. What are the next steps? Please contact us for a jump start to your assessment. We also provide AWS immersion days. You can go to our website, www.clockwork.com. Email us at info@clockwork.com for any further queries, or if you'd like to just get started with a discovery process for your AWS migration. And thanks, Chuck. Thanks for giving me an opportunity to introduce the AWS migration services to our customers.